Okay, class, today we're going to be talking about the area of triangles. Now, as you're watching the video here, please make sure that you are listening closely, take careful notes in your guided notes, and if at any point you need to pause or replay something in order to truly hear it and understand it again, you can always do that. Most of you, or many of you, might remember the formula for the area of a triangle that says 1/2 base times height. It's a formula that we've commonly used, but I do want to go over where that formula comes from. So it does say if we were to take each of these, well, I'll just do the first example. If we were to take the triangle in example A and try to create a quadrilateral out of that, I could take the exact same triangle. So I'm just going to trace it real quick. Whoops. Sorry. I could trace that triangle. I could copy that. And then if I move that triangle around, flip it, rotate it, and slide it back in here, you can see that the two triangles together make one rectangle. Now remember, a rectangle is 1/2 base times height. Since my triangle here is half of that rectangle, it makes sense that my triangle is 1/2 base times height. So our first formula for triangles is the 1/2 base times height. Keep in mind that on this formula, like we talked about in the last lesson, the base must be perpendicular to the height. So we have to look for that 90-degree angle. In the triangle then that was given, this could be the base and the height because we can see the 90-degree angle. Okay, if we had a triangle like example B, and we called the base down here, the side at the bottom, in this case, we would have to actually find the height by using a variety of strategies, usually dealing with triangles again, to find that missing height. So that's the first thing I want to talk about. We're going to compare and contrast the steps that are required to find the area of right triangles from isosceles triangles, or even, in example C, an equilateral triangle. And keep in mind, it's going to come down to the main idea of, if we use our general formula, 1/2 base times height, how can we go about finding the height if it's not given? So if we look at our first example, remember that the height and base are perpendicular, so as long as you see the right angle, you know that these represent the height and the base. And if we plug those into the formula, 1/2 times 5 times 2, you can multiply in any order. I'll do 1/2 times 10, and 1/2 of 10 is 5. My units are feet, and we know that area is always feet squared. So that's the general use of the formula. Then we get to an example like example B, where we do have a base, okay, so the bottom is 2 feet, but we don't know what the height is. So in this one, we're going to need to draw in a height. This is going to be my H here. Now keep in mind, by drawing in that height, we're actually taking that base of 2 and we're dividing it in half. So this half is 1 and this half over here is 1. And then that allows us to take the original triangle and divide it up into 2 smaller triangles. I'm going to use one of those smaller triangles to actually find the height. So going back to just this first triangle here, if I use my Pythagorean theorem, my legs are 1 and my H. So I'll start with 1 squared, So if I do 1 squared plus H squared equals, my hypotenuse is 4, so 4 squared. That's 1 plus H squared equals 16. If I subtract 1, H squared equals 15, which means H is square root of 15. Now for the majority of this, we're going to try to keep exact answers. So for most of these problems, I'm going to say just leave it as a square root if you do not get a perfect square. Now I know that my height is square root of 15. Now in step 2, okay, I can actually go and find the area of the full triangle. And remember, I'm going to go back to my 1/2 base times height. Okay, I am finding the area of the full triangle, not just the little one in yellow. So the base of my full triangle goes back to being a base of 2. The height of my triangle is my square root 15. So I'm going to multiply these together. Now keep in mind that when you multiply 1/2 times 2, you're going to get 1. And 1 times square root 15 is the same as just saying square root 15. Again, my units are feet, so I'll do feet squared. So this type of problem is more of a 2-step problem. Okay, step 1 is basically find the height, and then step 2 is use that height to find the area of the full triangle. Okay, looking at another example. So this one is an equilateral triangle. Now, keep in mind in an equilateral triangle, if I was to draw my height, okay, which again, we don't know at the moment here, but we do know that an equilateral triangle is also equal angular. So we know that this angle is 60 and this angle is 60, and we know that the full angle at the top is 60, but when I drew in my height, we divided it up into 30 and 30. So for this one, I can actually find my height here by looking at one of my 30, 60, 90 triangles. Now you can do this a couple of ways. One of the things we talked about yesterday was find your 30-degree angle. The side across from that is my A. Find your 90-degree angle, and the side across from that is my 2A. And then your third side, my height, in other words, is my A root 3. So based on this information, if I come over here, okay, it looks like my 2A side is equal to 6 feet. That means that my A is 3. And if my A is 3, then that means that my height here is 3 square root 3. So step 1, again, step 1 was to find the height. And this time I found the height by using my special right triangle. So now I know that my height is 3 square root 3. Now step 2 is to actually find the area of the full triangle using 1/2 base times height. And again, remember that when I say the full triangle, the base of the full triangle is the 6 feet. So I'm going to be using the 6 for the base. The height of my full triangle is the 3 square root 3. When I multiply 1/2 times 6, I get 3 times 3 square root 3. And 3 times 3 square root 3 is 9 square root 3. My units are still feet. I'm going to do feet squared. So in all 3 of these problems, we used the same strategy, okay? It was step 1, find the height. And to find the height, you could use a variety of skills from Pythagorean theorem to special right triangles. And then step 2, you're going to use your area formula, 1/2 base times height. Okay, this can be used on probably a lot of problems, but I want to talk a little bit more about that third problem, the equilateral triangle. Okay, let's see if we could derive a formula that would work for all equilateral triangles so that we wouldn't have to do this 2-step process every time. So let's take a general equilateral triangle. I'm going to call one of the sides S for side. Since it's equilateral, all the sides are the same. If I draw in my height, remember that this is a 60-degree and this is a 30-degree angle, and I'm going to be solving for this height here. Now remember that the side across from the 30 degrees, that's my smallest side. That's my A side. Well, my A side is just going to be half of the full side. So I could call that 1/2 S. Another way I could write that is to say S divided by 2. Because all I'm doing is taking that bottom side and cutting it into 2 pieces. Now, knowing that that's my A value, to find my height, remember that my height is the A square root 3 side. So if my A value is S over 2, then my height is S over 2 times square root 3. So this means that the height of this triangle is S square root 3 divided by 2. Now, knowing the height of the triangle, if I go back to find, and again, I'm still using my 2-step process, but we're hoping that at the end of the 2-step process, we have a better formula to work with. So step 1 was find the height, which we've done. Step 2 is go back to my general area formula, 1/2 base times height. Okay, recall that the base is going to be the base of the full triangle. So we're talking about the base of S. Okay, and then my height, remember, is this new value that we just came up with. My height is S square root 3 over 2. If I multiply all of these together, okay, remember that when you multiply fractions, you multiply the numerators together and then you multiply the denominators. So if I multiply these numerators together, 1 times square root 3 is square root 3. And s times s is s squared. If I multiply these denominators together, 2 times 2 is 4. So a new formula that works for all equilateral triangles is simply side squared times root 3 divided by 4. This is a way, by using this formula, that we're really consolidating the 2 steps that we did up above so that we only have to do 1 step. Now keep in mind, this only works for equilateral triangles where all of the sides are the same. So if we looked at a new example, number 5 here, using this new formula, one of the sides is 6. I don't have to worry about finding the height. I'm going to use my new formula. My new formula says plug in that 6 for the side, so 6 squared times root 3 divided by 4. 6 squared is 36 times root 3 divided by 4. And if I divide 36 by 4, I end up getting 9 root 3. And my units this time are centimeters, which leaves me with centimeters squared. So I did want to point out that the example C up above and this example 5 were actually the exact same problem. They were both equilateral triangles with sides of 6. Up above, in example C, we solved it using the 2-step plan. And example 5, we solved it in 1 step by using our new formula. So at this point, we now have 2 formulas to find area of a triangle. Now we're going to start looking at just some other variations. If we take number 6, again, using what we've already learned, the 2-step plan, okay, this would be step 1, let's find the height, okay? In this problem, I want to find the height, and remember, if this is my base, and keep in mind, guys, if this is my base, then my full base is 6 plus 14, or 20. If that's my base, then this is my height. My first step is find the height. Now, here's a problem that we haven't seen in a while, but for this one, hopefully this looks a little bit familiar to you. This is a problem where we can use our little parachute man shortcut to be able to find that missing height. And again, as a reminder of what parachute man is, we're going to come down the height. We're going to come down this side. The side that we come down, that's what goes in my proportion twice. Okay, once we're down at the bottom of the triangle, we can either go to point A, that's my 6 centimeter distance, or we can go to point B, or C, I'm sorry, that's my 14 centimeters. And then we're going to cross multiply to actually solve for H. H times H is H squared. And if I grab the calculator here, 6 times 14 is 84. So to find the height, we will have to do the square root of that, which means that we have the square root of 84. That's not a perfect square, but I could break that apart into square, and I don't like the way I wrote that here. Let me move this. I could break that apart into the square root of 4 and the square root of 21, which means that my height is 2 square root 21. So step 1 is still find the height. Okay, now after step 1, step 2 is now find the area. And since this is not equilateral, we cannot use the formula that we learned just above, but we have to go back to the original formula of 1/2 base times height. Remember that the base of the triangle is that full side, right? You know, remember the base is this full side, so the base of my triangle here is 20. And the height we just came up with here, the height is 2 square root 21. So if we put all of that in and we just multiply, if I multiply half of 20, that's going to give me 10 times 2 square root 21. 10 times 2 gives me 20 square root 21. And my units are centimeters squared. So my final area here is this one. Okay, again, it's just showing you another way that we can use our 1/2 base times height, but more of the 2 steps where we have to find the height first. The last thing I want to do is discover an additional formula that can be used when we have a triangle with 2 side lengths and the measure of one of the included angles. So for example, let's say that you had a triangle where you knew the measure of angle A and you knew the measure of the two sides on either side of that angle. Okay, so we're going to kind of look at a problem where we knew this information. But we're going to kind of develop the formula ourselves. So once again, part A, we're going to start with the original formula for the area of a triangle. And again, that formula is just your 1/2 base times height. Okay, part B says draw and label a perpendicular line H from point B to AC. So going from point B, I'm going to go straight down to AC. This is perpendicular, and I'm going to call this H. Okay, this is the height of my triangle that I'm going to be kind of looking for. Now, remembering your trig functions, if I wanted you to write a sine ratio, okay, remember that the sine is the opposite side over the hypotenuse, okay? So I could write a sine ratio here that says the sine of A equals H over C. H was my opposite and C was my hypotenuse. Now, if I took that equation, if I wanted to solve for H, in order to solve for H, I can cross multiply. Okay, if I do over 1 and I cross multiply, H would equal, and then I would have to multiply these together. So C times the sine of A. So unlike the last example, this time we're identifying our H value by actually using one of our trig functions. Now, once you know what your H value is, so once I know that this is my H value, now I can actually go back to that original equation and I can plug that H value in. So I'm going to have an equation that says 1/2 times B times C sine of A. If you put all that together, we have an equation that says 1/2 BC sine of A. And do keep in mind that these are all being multiplied. So you need to remember that it's 1/2 times B times C times sine of A. We don't generally put all the parentheses in, but if it helps you to remember that you're multiplying those values together, okay? The other thing to remember is that in this formula, A is what we call an included angle. And that means that A is between sides B and C. Okay, so whichever two sides you're given, B and C, we need to know the angle between them in order to use this formula. Okay, so as a quick example of how to use this one, you might see a problem that looks like this. Now, this goes back to that whole tabletop, we talked about a company that's designing tabletops and all of that. We're not worried so much about that, but just kind of goes back to that a little bit. You'll notice that in this example, I am giving you an angle, and I'm also giving you the sides on either side of this angle. This is how I know that I can use this formula. Okay, area equals 1/2 times B times C times sine of A. Okay, my B and C are going to be these two sides, and since we're multiplying them, it really doesn't matter which one or what order I put them in. Okay, 5 and 7 doesn't matter. The angle that's between those, that's the angle that's going in with sine. So we're going to do sine of 49 degrees. And then we're just going to literally put this in your calculator, okay? These are going to always be decimal answers because we are doing the sine of an angle. So I'm going to tell you what to round to. In this case, we're going to round to the 10th. And if you put that in your calculator, let's see, 1/2 times 5 times 7 times sine of 49, we get approximately 13.2. Well, it's 207, so that basically rounds to 13.2 for my area. And again, my units were feet, so this is feet squared. I wanted to do just a real quick summary now of the 3 formulas that you've learned and when to use each one so that you can practice these on your homework here. So if you grab your word wall, if you don't already have it, you can pause the video and pull out your word wall. The 2 formulas that we learned first were the rectangle and the parallelogram. If you don't have those on your word wall, make sure you add those to that real quick. Remember that for both formulas, we're using a base and a height, but remember that the base and height must be perpendicular, so you have to see that 90-degree angle. Okay, now we're going to add 3 different formulas for the triangle. First formula for the triangle is the most general formula. This is the one where we're going to do 1/2 base times height. And just like up above, the base and the height must be perpendicular. So as long as you know you have a right angle, you can use the formula right away. If you have a triangle where you don't know the height, you might have to actually find that height first. So that would be where the 2 steps would come in. Now, if you have an equilateral triangle, so you have to know that all 3 sides are the same, or I could tell you that all 3 angles are the same, because we do know that if the 3 angles are the same, then the 3 sides are the same. In this particular case, you can use the formula that says side squared times √3 over 4. And in this case, you're just plugging in one of the sides. And then our final method is, if you're given an angle measure, we're just going to call it angle A. So you're given one of the angles, and you're given the sides on either side of it. Okay, so these 2 sides. Call it B, call it C. As long as you have that information, you can use the formula that says 1/2 B times C times sine of A. So what you'll work on tonight is applying these three different formulas. And at the beginning, I'll kind of give you a hint as to which formula to use. But then after that, you're going to look at a bunch of problems where you have to decide which formula to use for each one.